Okay, so you want me to repeat quickly everything?
It's okay. Like if you, it's okay, sir. You can continue.
Okay, sure. So what not to expect? I'm not going to give you big programs to execute, or we are not going deep on scripting or functions. And about Simulink, I am not going to give you sophisticated tools. There are so many tools available in Simulink, or both Simulink and MATLAB add-on tools, etc. And I am strictly focusing on very basics, and that too, I'm just creating a path for you to start. That is, I am embedding interest in each and every in you. Further, moving on. Yeah, these are the things which I am not going to speak, at least today, or both interpolation and other computation techniques, importing and manipulation data, or make a user-defined model. Question of the day: why do we need Simulink? Why do we need MATLAB? Thing is, during this pandemic, it is very difficult to go out and do used projects and all those stuff alone or with your friends. So there should be a medium where you can learn and study, even though it is not as efficient as you do it in hands, you do with your hands, but still there should be at least some possibility to do that. Here we'll just evaluate all things virtually and give possible outcomes beforehand. And there we are constrained to use, if we are going outside to buy something, we are constrained to use that substance. Once that substance is either fried or in the sense destroyed, there is no other choice that you have to go again and buy something. Then only you can continue the project. But here you can do anything and everything. You can fry as many devices as you can, because it's virtual. Hence we'll save the cost, and most of the times all the external factors like temperature, humidity, everything will affect our project or what we do. These kind of things are not viable or not applicable here, nor viable here. That is, we can give some emulation on external influence. Still, it is very little or minimal. We can do ideal things here, and thus we can do easy project implementation. And please be careful about it. Please listen to this carefully. Completing a simulation successfully doesn't mean complete a project. Simulation is just the beginning of a project. The more advantage is that you can be confident that it is possible. The solution is possible, but that doesn't complete your project. Once you are doing anything, you have to do with the devices. Coming to our subject, what is MATLAB? MATLAB is a tool. It's a generic, versatile tool. The word I should use here is versatile. It's a versatile tool capable of doing almost everything. We can do electric EV modeling or normal vehicle, normal vehicle modeling. We can do power system simulations. We can do control system handling. We can do computations. We can do data science, data analytics, data science projects. We can do even machine learning, deep learning. Anything and everything is possible with MATLAB and its sophisticated tools. MATLAB, for your information, it does not mean, at least some of them have, with the logic of MATLAB, you might have thought that it is Max Lab or Mathematics Lab. It's not Mathematics Lab, it's Metrics Lab or Metrics Laboratory, created and owned by a company known as MathWorks. It is a programming and numerical computation platform, and it's not new. It's very old compared to the technology which we are dealing with. It's released as early as 1984. It is normally used to analyze data and develop algorithms. That is a scientific way of programming. These are few things which are possible, as I said earlier, possible with MATLAB. Data analysis, we can explore, we can do anything and everything. We can torture data as much as we can. We can visualize those data. We can create an algorithm to create, we can program ESP32, STM32, all kind of embedded system, Arduino, etc. We can, without knowing basics of code, we can create an application which can run both on desktop as well as Android or iOS mobiles. we can integrate this with other programming languages like Python, C, Fortran, etc. Fortran is no more used, very less used, or Java, especially Python, C, C++, and Java. It is mostly similar to Python and C. And as it is also, we can also connect different kind of hardwares, and we can program those hardware with this tool. Rest are we can it's a cloud computing. We have a cloud computing platform within MATLAB. Desktop and web development is possible, etc. Enough talking. I know you started getting bored, so let me just go through what all you can. How can you start? I have said earlier in the WhatsApp group that is the concerned team has developed or created. I have sent you a link. So once you click the link, you will be redirected to this site. If you don't have a MATLAB account, you can do that. You can go to this hyperlink, click this hyperlink, and go to this site where you can create a MATLAB account. At least for trial, I believe you will get for 30 days. Just give the answers and etc. And to check if you have MATLAB license, or if your college or university have MATLAB license, just Google MATLAB University, and then the first option, first search result is, click the first search result, where you will get, you can check, just type the university's official name. There is no drop-up menu, so just type it, and you have to type the full name actually. That is whatever that is given in the official website of your university or college. I'm just weekly typing, please. Okay, and just your email. Within 1 or 2 hours, you will get this answer. You will get a result whether it is this license is available. If so, how to get that license and how to activate your MATLAB account. If not, you are always welcome to go for a trial. So that's about MATLAB. Once you create this, okay. Okay, this will be your dashboard, at least my dashboard. There is a metrics menu here where you can get all the things that is possible. You can go to MATLAB online. I know MATLAB is a big software. It will be very difficult even to download the crack. It is very difficult to download it because it is at least 11 to 13 GB without any additional tools. So if we are facing any problem, and if you want to start learning MATLAB, at least you can cover up to 20 to 30, 40%, more, close to 40%. There is an option known as, once you create the account, there is an option known as MATLAB Online. It's only activated once either you are in the trial or you have a subscription, that is license. And the other options are, you have online training, all sorts of webinars, and self-paced learning, which is very important. Like these are courses that is available, which while after completion you can get certificate and you can display your proficiency in platforms such as LinkedIn. So after I click this MATLAB option, this is what I get. It's loading. The interface of both MATLAB Online and MATLAB, as in my software, in my desktop, it is almost same, but I will be mostly using MATLAB desktop, because while using MATLAB Online and also streaming in the system, there might be a bandwidth problem, and that can cause a delay in this presentation. To avoid that, I might use MATLAB desktop, which is already launched. It's almost similar. There is not much difference. This is the command line where you will type the instructions. This is a workspace in the left-hand side, bottom. You can see there is something known as workspace. Suppose I define a variable. That variable is assigned in the workspace, and you can manipulate it either in the command window or in the workspace. I will show that detail in MATLAB, offline MATLAB, that is original MATLAB. And here you can see the folder where the data is stored. So in MATLAB Online, there is something known as MATLAB Mobile. So whatever data you are stored, you are saved in mobile, will be synced to MATLAB Cloud, which you can access in this folder. There is a nice way of using our mobile to access data or sense data like speed, velocity, high time, etc. So many things are available. hopefully I will explain you tomorrow regarding that. So this is MATLAB interface. Let me go to this is MATLAB to R2021B, that is the latest version, latest version. So as I said, this is the command window, this is the workspace and current folder. So to start MATLAB, this is where you type instructions. You can assign a variable. Let us assign a variable, say A, which is equal to 5. So once you assign it, okay, it's already I have some variables here. So let me clear that. To clear variables, you can give CLEAR, clear. Okay, once you are given clear, the entire workspace, whatever variables you have defined earlier, is now deleted or is now cleared, formatted. And you want to clear this command window. After some time, it may seem that these are all crowded. So to avoid that, just give, I believe, CLC. Yes, CLC. Yes, CLC means clear screen. So clear screen is a function used to clear the command window, and clear is a function used to clear the variables from workspace. Now, while again defining, say, variable 5 equal to 5, this variable is displayed in workspace. You can either change here, where A is equal to 7, or you can also change here. Once you double click A, you can every variable in MATLAB is saved in a matrix format, like in an Excel kind of thing. N by N matrix. I believe you know what is a matrix is. It's a kind of mathematical illustration, mathematical tool to store data for many purpose, which is used in almost all fields, like electrostatics, electromagnetics, mathematics, mechanics, etc. So you can either change it here, like if I click 11 and just click A, you can see that A is now changed to 11. So that's how this platform works. And as I said, this is everything is a matrix here, or is a vector here. So you can also define multiple variables, like as of row or column matrix. Like I want to create a variable B which has values 1, 2, 3. So now the B is saved here, which has a value 1, 2, 3. And or I want to create a matrix. This or like a string line, like a row or column. Yes, row matrix. Say I want to create a original, just which look like a big matrix, like 1, 2, 3. If you give a semicolon, it's another row. To separate columns, you can give space, and to separate rows, you can give semicolons. So now you can see we have created a 3 by 3 matrix, which consists of these are elements, and you can index it. You can take single elements, like if D is equal to, say, C of 1. Okay, so C is more. You can see it's 1. You can take element by element if possible. There is another kind of function, inbuilt function within MATLAB known as rand, or random functions, to generate random metric variables. Like if you want a n by n matrix or square matrix, if you give 3, you will get a 3 by 3 random matrix. This is the random matrix. Or if you want to give a specific row matrix, you can give 1, 2. You will get a row matrix. I believe I'm clear. So that's the basics about what MATLAB is. And now we can go for its operations on these kind of variables: addition, subtraction, multiplication, matrix all multiplications are matrix multiplication. We can also do element wise multiplication. So let us define, say, let me clear the screen. Let us define, before that, you can also, rather than typing 1, 2, 3, if it is uniformly distributed, you can give 1 colon 3 means you will get you will get numbers from 1 to 3. Say, for example, if A is also equal to 1 to 100, if you want to give value to A, this variable or this, you can consider consider this as an array in either C or a list in Python. A is equal to 1 to 100. So it is not it is not convenient to type 1, 2, 3 up to 100. So one of the easy ways to give 1:100. So you'll get all the values from 1 to 100. So now A is equal to a random 3. So you will get a 3 by 3 random 3 by 3 square matrix. And B is equal to random again 3. So you will get another matrix. And you can add the same if you for that. A plus B gives this. A minus B. We'll subtract it, and A star B gives matrix multiplication. But if you want element by element multiplication, what you have to do is that A dot star B, then you will get like 0.3119 plus 0.0546 element by element. Normally, as we know, matrix multiplication is different. It's not like we are multiplying this element with this element and this element with this element. I believe you know the formula. It's different. So based on that, if you want to give element-wise multiplication, A dot star B. That's the instruction. The star A dot specify that it is multiplied element by element. Now you will get element by element. That is, if you multiply 0.3, if you add, let us show you, let us give an example. If you want to add 0.3119 plus 0.0546, you will get, I'm not getting that. Okay, sorry, it's multiplication. I'm sorry, it's multiplication. Okay, just A dot, okay, let me just multiply this. Yeah, see, element by element by element. So that's how you multiply that. What all are left? Yeah, zeros and ones. Okay. You can also define, these are the things which you will learn in your control system lab or advanced for CUSATians. It is advanced control electrical engineering. These are the basic things you are about to learn in either in the final year or in S6. Sorry, S7. If you want to have a zero matrix that contains all the element zeros, just give 0 of 3. So you will get 3 by 3 matrix containing element 0, or ones of 3, you will get 1. So these are the things which is available for us. So that's about, so these are all command window, right? So every time you are just typing something, you are getting answer there. So you are not able to continuously type a script or write a set of instructions and execute it. We have to do it line by line. For that, we have something known as scripting. And if you don't want to show the results, say for if I type A equal to 5, it's showing A is equal to 5 beneath my statement, or A is equal to 5. So you want to avoid that, you can give a semicolon. So it will, nothing will be shown, but A will be stored as 5 here. And oh yeah, so if you can create something known as live script. If to give continuous instructions, you can give something known as live script. And there you don't, you have to run a program, just like a program. Even though you click enter, the results won't appear. You have to run this program. Say x equal to 15, or okay, x equal to 15. And you want to display that. If you run this, nothing will happen. X will get stored here, but if you, even though you type X, it will be an error. So for scripts, if you want to display something, just like in other language, there is something known as print function. Here we have a function known as display function, or abbreviated as disp. If you give disp of X, that is display of X, and you have to go to live editor, there are so many options available, like home, basic functions are available. You can also start Simulink from here, and also other add-ons. There are plots to if you are working with graphs, to manipulate those graphs, you have these kind of all kind of possible options. You can, for advanced options, there you can install apps, all kind of specific apps. Like, I'll discuss some of them. A few of them I'll discuss tomorrow. Like that, you will have all kind of options. Just explore while starting this. Okay, in the live editor, there is something known as run. So if you run, you will get the output here, right? X equal to 15. That is, this 15 is the output. So if you don't want to show X equal to 15, just run it again with a semicolon. Now the output is only shown because X equal to 15 is avoided. So that's how you do. Let's go to how, let's study about basic plotting in MATLAB. That is how to create graphs in MATLAB. Let me first clear here so that all variables are cleared from workspace. What do you say X equal to 1 to 100. That is, you will get value. If you print X, you can see live editor run. You will get all the values. It's a row. It's a row matrix. Come 1, 2, 3 up to 100. And you want something like y equal to sine of X. It won't be a proper sine wave. For that, let us do one thing. Let us give. There is another option. Let us give pi. Okay. If you type pi, it's pi 22/7. You will directly get it. You don't have to define pi is equal to 22/7 or 3.14. It is an inbuilt function, and the system knows that pi has the value 3.14. Pi by 100, 2 pi. 2 star pi, 2 into pi. So what this statement means? This means X has a value 1 to 2 pi with each value has a gap of pi by 100. That is up to 1 to 2 pi. That it is due to we have or about 200 values, because 1 to 2 pi means 1 to 2 pi has so many values, and each this entire 1 to 2 pi gap is divided. Each element is divided into pi by 100. So the total data points you are going to get is 200. That what I said. This it's simple mathematics. Just multiply. How you can get pi by 100? How you can change pi by 100 to 2 pi? Just multiply by 200. You will get the answer. You will get the answer 2 pi. If you multiply this pi by 100 with 200, you will get 2 pi. So that means it has 200 elements in that. So if there is another function to plot a graph. There is a function known as plot, and if you give y, and if you run that, you are going to get a sine graph from 1 to and okay, the other one is correct. This is wrong. Okay, so you're plotting this graph where y is equal to sine x. If you want to plot that, you can just give the function known as plot. So if you don't know what what plot is, or if you don't know what any function is, there is something known as documentation search button here. If you type plot and click enter, now you don't need an internet for that. It is pre-built in MATLAB software. There is so many plots are available, like plot in 2D, 2D line, whatever tools we are, which is there in MATLAB, and there are multiple functions. You can get multiple options. So we are using plot 2D plot. Okay, so they will explain you what plot is, description. It's loading. Sorry for the delay. Yeah. Like what all are the examples? Like they are also giving examples to us. This is the example I gave you. You can try to yourself once you open the script. It will open directly from this document area, and you can explore, you can change the variables, you can do everything with this. And if you run this, the plot x comma y, where x is the x-axis and y is the y-axis respectively. We got this kind of graph. Okay, that's with plotting. And if you want to change its color, you can find that document. What all are the possible options available? What changes you can do, etc., are given here. You can format it in any way, like x comma y color. If I give, say, red, plot y comma red. Red, R stands for red. Okay, and if I run it, you're going to get a red graph. And the format, you will type the plot, you will get the format, what all are the options available, etc. Those are all found in documentation. You can manipulate it in all possible ways. And right now it's a continuous line, a solid line. If you want it like zero kind of structure, if you give O, you are going to get, instead of solid lines, you are going to get circuits. This is just by giving O. So that's how you can manipulate plots. And that's about plots. Now we can dig some more to some level to like conditional statements and all. Just like I have already taken the conditions. So in order to save time, I am just opening those programs which I have already did. Okay, I think there's somewhere. Let me just create one new one. Say if a variable, we are not defined that variable, we have to define it somewhere. Is greater than 15. Display this format is like this: if as the condition and the result. Display 15. Okay. Else if, there is something known as else if, same like this, else if condition less than 50, and display is print compared to other programs is just print, say 12. Okay, don't bother about what I am typing, just understand the logic. Else display nothing. So just like, it's almost similar to C, almost, but we don't have curly brackets, and if you want to end this, or if you want to close this, instead of curly brackets, the interpreter, the compiler knows the if statement is ended by giving an end statement, end. Only after giving an end statement, the system this will be correct, or this will be completed. This is same for a function as well as loops, that is for loops or while loops. So you can also, you may wonder, is there any option to give values, like to accept a value number. Here number is not specified here, neither in the workspace nor in the script. So how to take it from the user rather than defining number is predefining it like 25 or anything like that. How you can accept it from the user? It's very simple. Just give input and the number. Oh, sorry, it's number. So the script is, I believe, okay. We won't have any problem. Yeah, in the command window, it will appear under the number. If let me give 56. Number 56. 15 is displayed. Since the number 56 is greater than 15, 15 is displayed. We can try it once more if you want. 12. If the number is less than 12, it is 2. Hence, that's how you will do if statement. Switch statement is also possible. And while normally none of them, if you are doing a big kind of project or if you're working with MATLAB, whether it is your job, you don't do this small script, any small script. It will be either 100 or thousands of line bigs. So it is very difficult to troubleshoot if you are continuously writing down a program and evaluating it. It will be very difficult. So we can divide this script into small scripts known as subsections. It is very simple. Just give 2% and give enter. So the script is divided into 2 portions, and you can together run the program, or individually you can run the program. So here okay, num cannot, okay, both num and switch cannot be accepted at the same time. Okay, that's right. If num apo equal to, say, Monday is 15, and you can give conditions accordingly, like if this this statement is this, like that. Okay, and you have to specify apo somewhere here, like say I explained it because here the num is accepting as a number or an integer, but Monday, when you type Monday in the command window, it will be a string. So how to differentiate both string or integer here? Just give s. That's how. If you give the after your dialog, if you give s, then the number will be stored as a string, else number will be stored as an integer. Now when you accept num, it's not num, it's apo. Apo, you will get the answer. You have to also give let me check if that file is here with me. Conditional. Yeah. Other this is what the earlier which I wrote. I accepted a number alpha. Otherwise, okay. I accepted a number alpha and displayed a random thing. So you can give so many options. If you have only one option, or if your switch cases are complete, you can give otherwise. Otherwise will be the default condition for switch. That's how you write switches. Since we have very less time, I'm just running. It's almost 4:45. I have to introduce Simulink as well. There is something known as we'll move on to loop. So now we have learned how to create a variable, how to work with plots, how to give conditional statements, and finally we are going to introduce loops, just like for loop, especially for loop. Say x equal to 5 is a variable. You want to display this x 5 times. That is the program I'm going to do. for n equal to, that is I equal to 1:5. That is, I will change. This is the format for condition, the integer and how many times it need to be repeated. 1:5 means 1, 2, 3, 4, 5. It will it is, I will change from 1 to 5. Display x, and as I sorry. So for I changing from 1 to 5, this is the syntax of how we write for here. We know that there is a error here. The error is we are not closed it. So unless we give end, this won't work, and that will be an error. Once we end should be given parallel. It should be intended parallel to 4. And if you can scroll down, there is an error here. We'll just run it and we'll check. It's not an error. Okay. So now you can see that in each loop, each cycle, the 5 is displayed. The I is changing from 1, 2, 3, 4, 5. That's how you describe the loop in here. Same is to while is almost same. While condition, or if it is a single condition, you can write while I is greater than 5. But before, while using y, you have to initialize the variable which are going to increment. Just give the condition display x and n plus 1. You have to increment it. Okay, n equal to n plus 1. Normally, for loops are used where you know the exact number, how many times it need to be iterated, and while is used where you don't know the exact number. That's how you these two looping structures are used. Just like for, you have to end it. Okay, I will run that. Okay, it's n. I didn't increment I. There is an error. Display x. While I is greater than 4. I gave I greater than 5. That means the condition is initially true, so it is not running. I is 0. I is not greater than 5. It is false. So that's why this was not running. So that's how you troubleshoot things. Yeah, it is working. Here, if you don't want to display at I equal to 0, you will get 5 for the one time. I equal to 2, I equal to 3, I equal to 4, I equal to 5. This condition is greater than or equal to 5. While condition, you have to give greater than or equal to sign. That's default. So I believe you understood something about all the 4 things: introduction to variables, conditional statements, loops in the switch, that is if and switching statements, for loop and while loop. Now we'll move on to Simulink. These are the basic functions or the basic programming concepts within MATLAB. Now, normally what we used to do in our BTech projects, whether it is EC or EEE or CS, whatever it is, we'll work with both with MATLAB and Simulink simultaneously. So Simulink is an integral part of our projects and our working. So to start Simulink, you have 2 ways: open MATLAB, go to home and click Simulink, or simply type Simulink in the command window and click enter. So Simulink is opened, and if you are a fresher in Simulink, the first thing you have to do is you can go through the examples. That's the best way to understand Simulink. Or you may think these are all kind of difficult projects, or difficult examples, but everything is given in each what this project does, what is the outcome, everything is given in detailed documentation within these kind of softwares, these kind of exams. And if you are not convinced, or if you are not able to go through this, or it is very difficult to understand, there is something known as learn option. Simulink OnLab is an interactive platform where you can simultaneously learn through videos and hands-on experience. You will be, after a certain video, you will have, there will be some questions which you have to carry out, and after this you will also get a certificate of completion that you have successfully completed Simulink. Simulink is very important for us, and SimScape is important. And if you are going deep, state flow is also very important. You can also go through, because these are all for base. There is no prerequisites to go to understand or go through these chapters or these courses. Simulink, SimScape, and state flow. MATLAB also has on-ramp, which is available in MATLAB online portal. So, here we are going to create a model, a blank model. But if you're starting, if you have time, just go through the examples or just go through these courses. You'll have much better view on what all the things we are doing and what all these softwares are capable. So this is the Canvas. This is known as Canvas. The place where we are going to work is known as Canvas, and these are the options available on the toolbox. It is known as toolbox. Here you can see the simulation tool, debugging tool, modeling tool, format tool, apps, etc. Apps is also available in MATLAB, where you can integrate external applications developed by other developers or software engineers or MATLAB practitioners, and you can integrate it within your MATLAB. The first thing is MATLAB is a software where Simulink is a software where you are dragging and dropping certain elements, connecting those elements, and getting output through scope or display board, etc. So the first thing is the library browser contains all sort of functions which can be used within MATLAB. So if you find that basic functions, that is Simulink will be available for all. But as we go further, the more libraries we download, as the MATLAB file the file is 15 GB or 20 more than 20 GB, then we are going to download all sort of toolboxes. Actually, these two toolboxes are not. It is project specific. If we are doing something on embedded system, we need an embedded coder. If we are doing our project on deep learning, or computer vision, we need that kind of tool. That will be easy. And these are the tools, and this tool, Simulink support for Overview. This is an external tool which you can download in the add-on session. I will be explaining that tomorrow, how you can without doing any coding, how you can program an Arduino to work on a servo motor or work with LEDs, etc. So these are all inbuilt packages in Simulink. So that's it. So we are only confining to the basic blocks which are used in MATLAB. There is some sources and sinks. Sources power, it can be a power source or what powers the software or powers the simulation. Normally we are using constants or RAM, the test signals. In control systems, when you are learning control systems, there is something known as test signals, which is used to test the signals, and mainly that is impulse signal, step signal, and RAM signal. These are the main signals used, so that you can see that, or this, whether it is sink or source. But as you get used to MATLAB, you won't go for just conventionally go to the browser, search for the respective block, respective folder, and get the blocks. Rather, just double click wherever in the canvas and just type, you want a step signal, just type step. You will get all the words, all the tools which is starting with step. So we want something on a step signal. So step. You also want to just know the path. Okay, you can also refer the path where you can get it. So in the library browser, in the Simulink folder, within sources, there is you can get this block. So you just type step, and you can get the step. And you want multiple outputs or multiple inputs. You don't need to kind of copy, just click control and drag it. While clicking control and drag, you can get as many copies as possible. So what I'm doing is I'm pressing control with my left hand and I'm dragging with my mouse. So that's how you can get copies as much as possible. So for the time being, we only need one tool, that is one step signal, that is the input. Here we can also give user-defined inputs, but for the time being, for explanation, I am using an inbuilt input, which is known as step signal, which constantly we can manipulate or change the variables in step signal. So step time and final value. Final value is the value which is the output. So here it is 1. And step time is 1. We don't have to bother as of now. Okay, just give up if you are changing something. Just give apply and okay. Else, if it is the old one, just give okay. Okay. Now we are going to let me show you some other blocks such as sign blocks. If you want to see a sign block. It's sign. There might be so many sine waves available in all kind of libraries. The more you download, the more options you get. But we need the basic sine wave tool, so that will be in Simulink sources. So you are getting the basic sine wave. You double click it, you have the option to change the amplitude. I want it the frequency is 1 radian per second, let it be so, etc. So you have this kind of all the options, all the properties of sine wave, which can be changed at your convenience. So, and the way you connect it, just there's a point here, just drag the mouse cursor to there and just drag it. So you can see there is an arrow popping up. You can edit that arrow and give input, name the signal. These are all signals. These lines are known as signal lines. You can give the name, respective name as say input. If you give input here, that means that this variable has already changed to input. Now you want to see the signal. How you can see the signal? Normally, how you can see the sine signal or cosine signal, which is created in wave generator, is using a scope or an oscilloscope, right? So just like that, we have something known as scope. Scope is how you can see output within MATLAB. There is scope, there is display. If it is a value or a numeric value, there is something known as display. If it is a continuous value, you can use scope. If it is a single value, you can use a display here. But as of now, we don't want display, but still, since it is not connected, it will ask you to connect. And if you want to create a junction, just give control and link it. Okay, this is not possible because this is for timing. Let me cancel that. It is because sine wave simultaneously changes. So that change is not accepted in display. Display is something where you give constant values, where the value is constant or where it is not changing rapidly. But here sine wave is changing rapidly from 0 to 1. The values are changing from 0 to 1. So that's why we are using a scope. Scope is preferred. Now we can run the simulation. And once sine wave must be okay, there is some the file containing block diagram Spring is shadowed by a file. I'm not opening Spring still. I already created a earlier file known as Spring, so that is creating a problem. So just always remember that whatever files you are creating, just remember the name and give it small names. Don't there is a after when you are creating so many documents or so many program files, there is a chance that one file may interact with the other and may cause simulation problems. Everything is correct. 0. We are still facing this error. I don't know why. Source of sine wave must be digital clock when sine waves. Sambo. Okay. Time based. Okay. No, it is. I'll explain what happened now. Okay. Why this error. Here what is happening is you are getting the input directly. The sine wave is not working because we are not given the exact frequency. Let me give something like sine 2 pi. Yeah. Here you can see that it is okay, but it is not a proper sine wave. Can anyone say why we are not getting this proper sine wave? What can be the cause? We are getting somewhat like sine wave, but we are not getting a proper sine wave. This is because of sampling time. What is happening inside Simulink is that we have an equation known as sin x. So sin x is simulated n number of times. And in 1 millisecond, sin x is solved. Like sin x value is given x equal to 0.01, and that value is displayed over here. And like that, we are getting so many points, and that points are being joined together to get a graph. But in default cases, the sample points will be very less. So it can cause problems like we are not getting suitable sine waves. So to overcome that, we have to increase number of sample points or increase the how in what interval this equation is getting solved. So for that, what you have to do is you have to go to the model setting in modeling, and there is something known as solver details. Okay, the first thing in the solver details, there is some maximum step size is auto. Just change it to some 0.01. That is in every 10 milliseconds, the equation have to be solved. That's the actual meaning of that. So whenever you try to solve anything in MATLAB or in Simulink, if you encounter this error, most of the times you will encounter this error. Just make sure that now you can see it is almost close to a sine wave, right? So that's how you will initiate the sine wave. Now what I did was I give internal simulation time. I didn't give any external function. Like I didn't give any input, rather it is taking time itself as a function of x. Earlier I give step signal. So what was a step signal? Step signal is you will get 0 to 1. So there is no change, right? You are getting 1 throughout, and that value is constant value is given to sine x. So say sine pi. Sine pi is 0. Yeah, sine pi is sine 180, sine 180 is 0. So throughout the cycle, throughout the 10 seconds, this is the simulation time. You can this is the x-axis of the plot. This plot x-axis is described here. So if you want it 20 seconds or 30 seconds, the more the time you give, the longer it takes to simulate. That's the only difference. So the thing is, earlier I give a step signal, which is a constant signal. If you are giving a constant signal, there is no change. So every time the value remains the same. Say sine pi is 0. So sine pi is sine 0 is repeatedly plotted on the graph continuously. So that's why you got a step like 0 throughout the simulation. Now, if you give a ramp signal instead of a step signal, and if you run it, you will get the same. You will get a sinusoidal wave. That's how you introduce. Just remember the mistake I did. Rather than using a continuously changing signal, that is a step signal. Sorry, that is a ramp signal. I use a step signal. Ramp signal is a linear signal. Like in 1 second, the value is 1. In 2 seconds, the value is 2, 3, 3, 4, 4. Up to it is gradually linearly rising. But a step signal is something which is constant throughout. So there is no change. So the point remains constant. Now you want to see multiple sine waves, say within the same scope. What I do is I press Control. I'm creating another sine wave, and here, when you double clicking, there are so many options available here. You can scale it, you can drag it, etc. You can also, if you go to the settings, if you go to the settings, you can change the number of available ports. Number of input port is 1. If you change it to 2, say, give OK. It's a bit slow for me. Okay, now you can see you are getting 2 points. Now you can connect this. Now both these waves are same. To change it, what I'll do is I'll give say the frequencies 200 pi. And I'll simulate it. Simulink, yeah, here. You need to change it to set time only. You have a ramp signal, you have a step signal. And when you run that, okay, let me change the scale. So okay, I forgot to say you to change the parameters. Just double click and change it accordingly. Okay, what the frequency, what is the frequency you want, what is the amplitude you want, etc. Yes. I don't know what happened. There was some problem. This is our old figure, and this is the new figure, right? We saw that we are able to see two signals in one graph. Okay, that's how you can while changing the number of inputs, you can do like this. Suppose you want to add these two signals and see the output. How you can do that? For that, we have something known as sum or add. There are two things. You can either use sum or you can either use add. Function. This is a sum function. You can, what you can do this, you can delete this path and you can add these two signals. So what you will get is not a pure sine wave, but a mix of both of these waves. It doesn't matter even there is an two inputs. You can give maximum of two or minimum of one. One is also okay. You can either delete this port or you can keep it as it is. Yeah, this is the sum. When you add these two signals, this is known as amplitude modulation. When you're adding these two signals, you are getting these kind of signals. That's how you add two signals. And there is also one. Suppose you have one input, that is, you have one input, but you need to show two signals. So what you should do, right? Just like this, you have one input, but you need to show two signals in the same graph. So what you can do is there is something known as mux, multiplexer. When you give mux, you can and connect this. You have an added advantage to show this graph. You can show two different signals in one graph. So what I discussed how to show sine wave, how to use add sine waves, and how to use sine wave, how to show two sine waves or with only one port. As early what we expected in the first time, we are getting two different graphs in the same plot. So that's about graphs. Since we are having 20 minutes more, let's give a small, rather a big let's do a big project. Like, we'll open a new Simulink model, Simulink page. Okay. Before that, this is the problem we have to go. Since I believe you all are from either second years or third years or even first years, I can't give I can't explain difficult control system problem. Rather, I am going to explain a simple mechanical problem which is explained in mechanics, engineering mechanics. We have a mass, a block of, say, a block of wood connected to a spring and a piston which inside we have fluid. Okay, we have a piston which this is known as a damper, which have a piston and a fluid inside the chamber. So this surface is rigid. So when a force is applied, so a force F is applied vertically downwards to the surface of mass M, the string and this damper will store energy, and once we release it, it oscillates. The spring will oscillate and the damper will also oscillate a little bit. Okay, so we have to we have to track the displacement of spring, how this is oscillating. Okay, that is what we are going to do. Okay, so what we can do is I have just ignore this part for the time being. This is a system. We can also add photos if you want. There is something in Simulink, there is something known as image. Once we click the image icon and we drag that block here and we double click that block, it will go to our media of our computer and we can search it accordingly, okay, as required. I have pasted this picture. This is the picture of interest. And we also need the we have to, in Simulink, everything is solved as differential equations. So that is one of the disadvantage of Simulink, which we are going to overcome using either Simscape or Stateflow or Powertrain, etc. The extra tools available with MATLAB. So whenever we need to solve anything or we need to model anything in Simulink, we mostly prefer differential equations for that physical representation. We have a mass here, we have a spring here, we have a damper here. We are also giving an initial, there is an initial change x, okay. Initially, the spring is displayed x downwards. That's what this x means. So to convert that to an equation, let me just find that. Just give me a moment. I have taken photo of that picture of interest. It's in downloads. Just okay. Anyway, we'll sort out this equation then. There is a force F. F is equal to, the equation is dx by dt square plus c dx by dt plus kx. That is the equation. We have the spring. Displacement of spring is given by kx. The damper is given by dx by dt of c dx by dt. And the acceleration produced in m is given by m dx square by dt square, or ma. It would be better if I would show a picture that will that has the equation. I have taken a picture here. Just give me a moment. I will find that picture and I will come back to you. For the time being, I am stopping the sharing. Give me 2 seconds. Got the picture. Just let me know once the screen is visible. For easy illustration, it's better to have a picture of that equation, how that equation came. I have written that. Sorry, my handwriting is not that good. Please bear with me. So this is the equation. We have force F with m x double dot. X double dot means dx square by dt square, and b x dot plus kx, where b is stands for b, or either b or c, and normally damper coefficient is given as b, so I given bx and spring constant k. This is the equation. Ideally, let f equal to fp0. So dx square by dt square, that is double differential of displacement is acceleration. Dx by dt gives velocity, and dx square by dt square, that is dv by dt, gives acceleration. So this dx square by dt is given as a, dx by dt as v, and x as x. Now we want to rearrange in such a way that the acceleration is in one side and the other values are the right side. Thus we get a is equal to 1 by m minus bv minus bx. So we have written down the equation we want to give to develop the system. So how we can one of the way we can develop, or we can create a block to illustrate differential equation is using the integrator block. If we integrate acceleration, we are going to get velocity. If we are integrating velocity, we are going to get displacement. The opposite of differentiation. If you are looking it in the left way, we are differentiating, and if you are going in the right way from acceleration to velocity, how to get acceleration velocity from acceleration? It is integrating acceleration. How to get displacement from velocity? It is integrating velocity. Thus, we are going to integrate this for the same. So there is a block known as MATLAB is stuck. I think I have opened so many things. Don't try to avoid opening so many MATLAB files, because MATLAB is going to take so much of your system memory for process. Even you have 8 GB of RAM, it may cover up to 5 GB. Even if you have 12 GB of RAM, it may cover up to 10 GB. So it's that kind of software. It's very difficult. Okay, now it's getting slow. Once I deleted or closed all those extra tabs, still the system is slow. I'll do one thing. I'll just okay. It's only the of that. Okay, that we'll open Simulink once more. Okay, MATLAB is closed. Great. Sorry for the delay post. I am having some difficulty with opening MATLAB, since it is consuming lots of. The more tab you open, the more the memory get filled, as I said earlier. For the time being, we'll try to do with MATLAB online. By the time we'll work, the other will. We hope the other tab will get open. Thing was, I was not using MATLAB online just because it is that slow. MATLAB is not open. This is MATLAB online. Yes, MATLAB is finally on. Since I'm also streaming, the net is quite slow today. Yeah, as I said, there is something known as integrator, which you can select, which integrates things. This denoted as 1 by s. We might need two integrators as we are using, we are twice. Acceleration is getting integrated to velocity, and velocity also is getting integrated to displacement. So just link it, and here you are going to get velocity. Just give it v. Okay, first you have velocity, and we need, from here you will get x, or that displacement, and displacement is there earlier multiplied with k. So to multiply something, we need something a block known as gain multiplying, and that is if gain is 6 and it is multiplied to a variable x, then the answer, the output is 6x. Oh, Simulink works. Simulink is initializing. So gain is something which multiplies a constant to a signal. If you are giving 1, it is multiply that signal. Whatever you are connecting to the, you can whatever it is connecting to the input, it multiplies that to with gain and gives as output. So for us, it is k. And we need to rotate it. For rotating, just press Ctrl plus R. What is the value given here? A k is 400, so we can directly give 400. And now we have a k into x. The outside is kx. This x. So we have kx. Now we want CV or CV. Yes, CV. So what should be done? There should be another signal taken from V, which is multiplied with C or B. That is with 10. Simulink of online is. That will be 10. One more. Okay, we have x, we have 10. Now what we need is minus, okay, we need to add this kx plus by. A is equal to 1 by m minus kx minus cy or by. So that's what we need is an adder. As I said, A is equal to 1 by m. So 1 by m is yet to be given. So we need another gain. Minus kx 1 by m. Say 1 by m is say the m let it be m 2 kilos. So 1 by m becomes 1 by 2. You apply. So that can anyone just take what we need from, as the end result is displacement, that is x. So to get x, or to read x, just take a scope and connect it to. If you want to take junction, just press control. Okay. So this is our circuit, but there will be an error. Can anyone say what will be the error? If you see that there is an error here, which I have done purposefully. The equation is m is equal to 1 by m minus kx minus cy. But there is something wrong. Can anyone answer that? What is wrong? Why it is wrong? A small thing has to be changed. You won't get the correct answer here. Hello? Is anyone there? Yes, 15 people are there. Can you answer this? Am I audible?
Yes, I am audible.
Okay, there is something wrong here. Can anyone say why? Can anyone say what is wrong? The equation, I'm again saying the equation is A is equal to 1 by M minus Kx minus Cy. Minus Kx minus Cy. It's I have given plus only, I have not given minus. Here you have 10, it is not minus 10, neither it is not minus 400. So I have to change sign here. If you double click the sum function, it is a Simulink is on. You can open. You have an option while double clicking this sum signal, you have an option to change it to minus minus. If you give minus minus, both of the inputs will change to minus. Okay, now it's everything is done. We can run the simulation. So what it actually does is for each time period or each second or each millisecond, we are given the simulation time has 10 milliseconds. For each millisecond, this equation is getting ran and the plot is illustrated, simulated. This is what I made in MATLAB desktop. The same, nothing is different here, except that I have given 1 by M, and I have taken 1 by M from MATLAB workspace. But instead of that, if we can, still it is slow. Let's compile this, just run this. And if we open the scope, yes, this is initially the spring is getting oscillated and it's coming to the steady state. So we have illustrated, we have designed a model which can real-time see what is the effect of a spring on a mass, on spring damper system. If there was no damper, then the spring would have continued. Ideally, the spring would have continuously oscillated. But with while keeping the damper, that the C constant thing, it will help to die out the oscillations. So we are getting this points. This is because we are not getting enough data points. So just go to the model settings and change the maximum step size to 0.001 or 0.02, etc. as your convenience. Actually, there is a very simple way of developing this. Okay, this is based on control system. With one block, we can what we can do is we can as I said earlier, there is mx, the first equation which I illustrated, mx double dot, that is m dx square by dt square plus c dx by dt plus kx. That is the equation. That is not, if you can convert that into a transfer function, just by giving the coefficient of m, if m is 2, say 1 by 2, m is 0.2, k is 10, c is 10 and k is 400, we can, if we run this block, This block is nothing but something known as transfer function. If we double click transfer function, I'll illustrate quickly here. I know we are running out of time. Just to complete this, there is a block known as transfer function, and if you double click it and changing the coefficients, the quotients given is like if you are giving 1 and 1, that means the value of x is 1 and the constant is 1. If you are giving 2, 1, 1, that means 2x square plus x plus 1. That is the mean. If you are giving, say, 3, 2, 1, 1, that means what is the variable? The variable is, if the variable is x, 3x square plus 2x, 3x cube plus 2x square plus x plus 1. That's how we are giving transfer function equations. For the denominator part. Okay, for all those guys who knows about transfer function, this is one of the easiest, very simple way to answer this question. That is, if we can give 1 by 2 plus 10, that is 100, and give apply, give OK. We have a scope. Just connect a scope. Just give say in a step. If you run this, we'll get the same answer. Almost kind of. It is starting from 1. Since the step is 1, the step signal is 1, so we are giving an impulse. It's almost same. The step time is 0, and if you run again, yeah, we are going to get the same answer. The spring is getting oscillated and dying out. So that's what happening in both cases. But there is a catch. Transfer function, if you know the definition of transfer function is only applicable when there are no initial conditions. But here we have an initial condition known as x equal to 0.1. So if there were no x, that is, if the initial condition is 0, if the mass or the spring is in the mean position, normal position, then we could have used this block. But since the spring is compressed a little bit from the start, what we can do is that we can give this initial condition in the closest integrator near to the displacement, and there is something known as initial condition. Here I have already given initial condition as 1. So normally initial condition will be 0. So for every integrator, there is something known as, you can type, if you check, double click and check, there is an initial condition which is 0. If you change it to 1, then the displacement, the concerned variable changes, initial condition changes to 1. Here what we are taking output from x, we want displacement. We want the displacement, that is x. So we are taking the signal from here to the scope. That's why we are getting the initial condition as 0.1 or point, whatever the initial condition. The block itself asks whether there is initial condition. If it is 0, then there are no initial condition. If it is 1 or 2, whatever the initial condition, we can apply. So you can illustrate a real-time spring change within with Simulink. This function is quite advanced. I know this how to use transfer function within Simulink. That's very simple. Just derive the equation. You don't need to develop a model like this. Directly give the transfer function and get the answer. So that's all for the day. I know I'm sorry for the trouble with which I got with my MATLAB, both online and the software version. Tomorrow we are going to check what a plan is, how to tune this, how to eradicate these oscillations, and if possible, how to model a power system, a small load flow. And now, right now, we need equations, differential equations. But normally for a physical system or for a system, it is very difficult to derive. As you know, I have to first write m, then a, ma plus ma minus b, BV plus KX. So we always want this equation set. So that you may think that that limits the possibility of MATLAB or Simulink. No, it's not true. There is something known as SimScape. SimScape, which we are going to use tomorrow, which normally for all projects we are more than Simulink. Actually, SimScape is part of Simulink. So no one is going to ask that we are not going to Simulink. We are going to take a special part of Simulink known as SimScape and going to physically model this spring dam system and a resistor, an LC system, and we will find the output. Finally, there is a surprise for you. We are going to program an Arduino using Simulink, and also I am going to explain about MATLAB mobile and how you can make use of your mobile phone to capture sensor value without any sensors. If you are a person who don't have a sensor to capture value, you can use your mobile and update data, and you can manipulate, you can get data and synchronize it in MATLAB online with MATLAB online and have fun with it. So if you have any questions, you can ask now. Else we can wind up. It's already 15 minutes late.
So if you have questions, go ahead with that. Please be sure to type your questions in chat box, or you can unmute your mic on speaker.
Please explore MATLAB, whatever I say you, even though I said you something about MATLAB, that's not enough. It will be there in your mind for at least 1 or 2 days, and when it comes to Monday, you will forget everything. Unless you try it yourself, you can't study a tool. That's what I learned after I went to the work I had. I'm a designer by profession, so I am using designer tools. So we used to have webinars or training sessions which they explained to us. But even though I thought that I understood that, and while I tried to do it when I got the software, it was very difficult. I called them again and asked these doubts. So unless and until you work on it, you start doing something on it, even though those other sources like SimScape, OnRun, I explained about some learning paths, right? Just go through the learning paths. Those are very good, very interactive. You will understand almost 90% of all the tools that is available in MATLAB. My sincere apologies for all those people. I took 17 minutes extra. I'm sorry. The MATLAB tool failed me today. Tomorrow, hopefully, I'll have some backups and I'll explain you in the given time. We'll end at 5:30 itself by tomorrow, or maybe even before that. Thank you.
Thank you, sir.
So great, we can wrap up the session. We appreciate everyone being here. So do join for tomorrow's session with the same link given. So a reminder will be given in the group so that you won't miss out. So thanks again for joining us today, and we will see you all tomorrow.